like to welcome everybody. My name is Andre Castro. I'm the Director of Communications for the General Aviation Manufacturers Association. I thank you for joining us for this press briefing. Today, we will have some brief remarks from GAMA President and CEO Pete Bunce, IBAC Director General Kurt Edwards, and then Bombardier's Head of Strategy and Analytics, Tomas Fissellier, will take us through the presentation of the comprehensive research and modeling that was done to support the updated goals of the Business Aviation Commitment on Climate Change, which was unveiled at NBAA Base last month. We would like this briefing to be interactive, so please feel free to jump in, raise your virtual hand, or use the chat to ask a question during the presentation. We will also have time for general Q&A after the presentation. Before going too much further, I would like to introduce Mark Uden, GAMA's Director of Government Affairs, and Bruce Perry, IBAC's Environment Director, who will be on hand to provide additional subject matter expertise. At this time, I'd like to hand it over to Pete.
Thank you, Andre. For those of you that were at NBAA Base, you recall that when we made the announcement on our net zero commitment for 50, we had said that we wanted to provide the press a more detailed briefing on the great work that the entire industry did, which was headed by Bombardier, to be able to refresh our commitments that were made back in 2009. Just to give everyone a little look back here, if those of you that have been around a while recall, in 2007, many of us were at the Paris Air Show, and we were truly stunned by the amount of environmental emphasis that we saw as we walked around the grounds at Paris. Right after that, many of us on the GAMA team decided that we needed to make sure we formed an environment committee, and that was quickly stood up. And we had asked at that time that Bombardier lead the effort. Bombardier obviously at that time was very heavily both in business aviation and in civil aviation, but also had a footprint in the US, Canada, and in Europe. So Bombardier was the ideal company to take over the reins for our environment committee and start leading the effort. We quickly decided that we needed to see how we, as the manufacturers with many thousands of business aviation aircraft flying all over the planet, how we could go and look at our environmental commitments and see what commitments could logically be made that paralleled what our commercial brethren were making. And so we launched that effort, again, led by Bombardier with participation from all the other OEMs. And later in 2008, that was briefed to the GAMA board, and the GAMA board voted to approve it and make sure that they had a commitment at that time that all turbine aircraft would be encompassed in what we wanted to do, not just jets. It would include turboprops and rotorcraft at that time. At the same time, we started a parallel effort that was led by the scientists from many of our OEMs, and Gulfstream led that effort to be able to develop a CO2 standard that will work for all turbine aircraft, and they worked that at ICAO, and that ultimately culminated in a standard. And those of you that have been watching the news yesterday, the administration or the EPA announced that it was going to stick with those standards that the last administration said that they were also going to stick with out of ICAO, which was good news for all of us, and shows that the work that was done was very comprehensive and met the needs for the industry as we go forward. So as we worked in 2009, we joined forces with IBAC to be able to declare that we would go ahead and move forward with three basic tenets, which was carbon neutral growth by 2020, an improvement in fuel efficiency per year of basically 2% year over year in the decade, or actually in the period up to 2020, and then a reduction in CO2 by 50% by 2050 relative to 2005. So we worked toward that goal, and then in 2015, we went and Bombardier led another study, again with all the participation of the OEMs, to look at seeing how we were doing. It was kind of a check to see mid-decade how we were doing, and then we looked at it again as we as we culminated in 2020, knowing that that was a year of COVID, drastic reduction in the amount of flying, so we had to go and take a look at that. But at the same time, we all know that the entire industry, all of aerospace, was looking for more significant commitments toward net zero. And so we actually challenged the entire industry to work together and ask Bombardier again to look at the study, see if the same metrics applied, and go put the science behind seeing whether or not we could go ahead and make a commitment for carbon neutral by 2050 now, or net zero by 2050. And what we found in that, and I just want to emphasize what a daunting task this was, because you're talking about thousands upon thousands of business jets, and Thomas is going to talk about that a bit later. We have a totally different problem than commercial airlines do with the way they go through their fleets and refresh their fleets, whereas how many aircraft we have out there flying. But the thing that I'm most proud of is that in the work that Bombardier did, every single one of the OEMs, including we had expertise from some of the new electric and hybrid propulsion companies that participated in the study that Thomas and his team put together at Bombardier. So we're going to talk about the details of that, and I'm going to pass it off to Kurt. But again, I'm glad that those of you in the press joined us, and please ask a lot of questions, because we want to make sure that this is understood by our community. And with that, Kurt, pass it to you.
Right. Thank you. Thank you, Pete. And thanks to everyone. Good morning to you. Thank you for joining us today. Business aviation has always been mindful of the need for greater efficiency, which translates into reduced or much fewer carbon emissions. We were the first technologically to make a lot of improvements to aircraft that bring about these developments. Think about winglets, think about lighter structures, think about aerodynamics and avionics that allow you to fly much more directly and therefore save on fuel. So we've always had that mindset baked into the industry. And even now, more than ever, Pete just mentioned how we got to our current goal starting way back in the late aughts. But now I think the awareness of moving toward greater ambition with regard to decarbonization is much more front and center. So it means that the 4 pillars that we laid out back in 2009 to meet those goals are even more important and more relevant today. So those 4 pillars I want to walk you through if I could. The first one is sustainable aviation fuels. We really need to make a lot of efforts to boost the production of it, raise the awareness of it, and develop the uptake in it significantly, as well as building the tools that will allow for our industry, which is characterized by many operators with very small fleets spread out all over the world and not necessarily operating to key airports where SAF is currently slightly available. It's not available in significant enough quantities, but tools like the concept called book and claim. So SAF is pillar number 1. Pillar number 2 is technology. The manufacturers in this industry are constantly innovating. So we appreciate all the work that they're doing there as members of GAMA to make aircraft more efficient every day. Beyond that, they're looking at innovations that get at hybrid power, electric power, hydrogen powered. These new types of power sources for aircraft will likely come to our community earlier, given that they can be adopted or adapted into smaller aircraft sooner. So we're looking forward to seeing how those innovations can contribute as well to the decarbonization of our industry. The third pillar is infrastructure improvements and operational improvements. This is where we want to see air traffic control agencies really buckle down and modernize the way that they control traffic, allowing us all to fly more efficiently, more directly, and more quickly. It also relies a little bit on the operators for finding ways to fly even lighter, and so or operate differently, such as single engine taxiing, all of which leads to decarbonization as well. The fourth area is generally called market-based measures, but we're looking at these as voluntary ways to help business aviation generally, which is a hard to abate industry since there's no real substitute right now beyond sustainable aviation fuels. But market-based measures such as voluntary offsets will help us demonstrate a commitment to decarbonization by allowing us to support reductions in other areas outside of our industry until such time as SAF has kicked in and there's sufficient amounts of it that we can use it, take advantage of it, and until such time as things like electricity and hydrogen kick in, and we can be also using those. So those are the four basic pillars that will allow us to get to the 2050 goal of net zero carbon emissions. And we need to work very closely with, and we'll need the support of our stakeholders, whether that's the governments, whether that's the manufacturers, fuel producers, fuel suppliers. It's going to have to be a very big cooperative effort to get us there. And so we're looking forward to working with all of our stakeholders to facilitate getting to our goal. And with that, I'll hand it back to you, Pete.
Well, thanks, Kurt. As we talked back when we were in Las Vegas, as we go and look at what the manufacturers can do, you're going to see in this briefing a very extensive array of what the manufacturers feel are technologies that are going to come forward with a best estimate based on all this participation of when these different technologies will come into force. And I also want to reiterate what Kurt just said about SAF and how the energy that is developing around SAF and what I think we as an industry, we in business and general aviation started quite a few years ago now at Van Nuys with our first demonstration, and then the different events, whether it's E-base or NBA base, where people are flying and uploading, and all of that now has taken hold, and our commercial brethren have also seen the absolute imperative of being able to go ahead and come with us on this journey with SAF. All of us know that they're really the key to this with how much fuel they burn in comparison to what we burn. But we're very proud that we really started this effort, and we have a lot of our operators that are already using the fuel. And as Kurt said, book and claim becomes absolutely paramount for the system to work, and for us as the supply chain and supply of SAF builds up, for us to be able to access it where it is available until it is ubiquitous and available everywhere. So Thomas is going to talk about that, the commitment that the manufacturers made to, again, a 2% year-over-year improvement in fuel efficiency is going to continue on through this next decade. And as we ramp up with sustainable aviation fuel and as we get new technologies into the industry, we're real excited for what we can do looking at our environmental footprint. And that's really what Thomas is going to dive into now with this brief. So with that, Thomas, you want to kick us off?
Absolutely. Thank you very much, Pete and Kurt, for the introduction. I have to say that I'm delighted to be with this crowd today. So thank you for inviting me. It's really a topic that's close to my heart because I've actually been in charge at Bombardier of updating the CO2 forecast model since about 2015. So that's a project that I've been living with for the past several years. And the objective of my presentation today will be to share with you our latest update on our business aviation commitment on climate change that was originally defined in 2009. So before I get into the details, I wanted to highlight that this presentation and this work is really the result of several months of very close collaboration across our industry. It's involved multiple consultations with other OEM manufacturers, engine manufacturers, and all of the key associations, namely GAMA, IATA, IBAC, NBAA, and NATA. So what I mean by this was really a team effort from the beginning. So if we go to the next slide, you'll recognize there the key objectives that we had set forward back in 2009, right? So 3 aspirational goals. Pete mentioned them, so I won't repeat them. What's important, though, when we look at where we are today as an industry, objective by objective. So on objective 1, which was to reduce CO2 emissions, we're basically on track to achieve or even exceed our 50% reduction target by 2050. I'll show you that in more details, but right now what we're trending towards is a reduction of about 70 to 75% compared to the 2005 levels. So really the questions that's left outstanding right now is that enough? We see right now many other industries that are actually targeting to achieve net zero by 2050, including the airline. So can we really be satisfied with 50%? Or even, as a matter of fact, with the 70% forecast trajectory that we're working towards? Or can we do more? So I'll come back to that in my presentation. On objective 2, we've actually achieved the 2% fuel efficiency reduction between 2010 until 2020. This is a major achievement for our business aviation industry, and we should be definitely proud of it. But while this is an amazing news that speaks to our industry's ability to innovate, the outstanding question becomes, what should we do next? Should we rest on our laurels, or should we instead continue pushing the envelope? And finally, on objective 3, again, we're on a trajectory to achieve carbon neutral growth from 2020. The question is, how do we maintain momentum? So if you go to the next slide, and I think Kurt has already kind of introduced the 4 pillars, you'll recognize them. Really, those are the 4 pillars to help us achieve as an industry these aspirational goals. I think what's important to mention here is the ones that have really the biggest impact on our ability to achieve the aspirational goals are the SAF adoption and the technology. Those are really the biggest ticket items. So in the work that we did this year with the industry coalition that we built around us, we really focused on understanding specifically these technology forecasts and assumptions and understanding the SAF adoption trends, because we really wanted to reflect the latest and greatest thinking in our updated model. So if you go to the next slide, you'll recognize this sun chart. You've actually seen it before. That's how we've been representing the CO2 emissions for our industry and our 38,000 fleet of aircraft. So, you know, what's important to look at is the formula that's at the bottom right-hand side. So in 2009, when we sat down as an industry to agree on how we would be calculating CO2 emissions going forward, we developed a formula and we agreed on a formula. And this formula has actually been kept identical since the creation of this commitment back in 2009. So in other words, year after year after year, we really ensured to keep the formula identical so that we could actually really compare how we're performing compared to the original 2009 commitment and how we're progressing also towards these 3 aspirational goals. Again, the second thing that you can read from this chart is that the 2 biggest drivers to achieve our goals are alternative fuel and technologies. So the question really becomes, since 2009, how have we been performing. So if you go to the next slide, you're going to see on the left-hand side a couple of lines there. So let me explain that a little bit to you. First of all, the blue line that you see here is our original CO2 forecast that we did back in 2009 for our industry. The orange line is the updated forecast that we did in 2015. And the gray area actually shows year by year the amount of CO2 emission, the actual amount of CO2 emission that has been coming from our fleet of 38,000 aircraft. So in other words, if I pick 2020, in 2020, our entire fleet of business jets and turboprops emitted a total of 16.4 million tons of CO2. The second thing that we can read from this chart is that pretty much up until 2020, our industry was in line with our 2015 forecast. And with COVID, obviously, we saw a big drop in the CO2 emission, really driven by the reduction in flight hours that we estimated at about roughly 25% reduction in flight hours in 2020. So where do we go from there? What we did next is we reran our CO2 forecast model all the way to 2050, really focusing on understanding what are the upcoming technologies that will be installed on our future aircraft, and how will these technologies help us as an industry reduce CO2 emission? And also, how will SAF adoption evolve over the next several decades? As these are, as we've seen in the previous chart, the two biggest ticket items to help us achieve our CO2 emissions. Not the only ones, obviously, we have four, but some of the biggest ones. So I'll start by taking you through the work that the BAC Industry Working Group Coalition did together on technologies. So if you go to the next slide, what you see here is the list of all the technologies that have been identified by the BAC Industry Working Group. And this was really the result of many discussions gathering the key players around the industry. So we worked with all of the OEM manufacturers, Gulfstream, Dassault, Embraer, Cessna, and Aerion, to name a few. We worked with engine manufacturers, Rolls-Royce, GE, and all of the key associations, as I mentioned. And our BA Bombardier engineering team reviewed all of the key systems in an aircraft and looked at the upcoming technologies, their maturity, their expected entry into service dates, the models and the types of aircraft that would be benefiting from these technologies, as well as the expected CO2 emissions to be derived from these technologies. And they identified two scenarios that we call here low scenario, which is basically a conservative scenario, and then the high scenario, which is a more optimistic one. So if I just take an example to kind of walk you through how this file works. Within the aerodynamic category, the team working with the coalition basically identified 5 different potential technologies improvements that are listed here: wingtip devices, natural and hybrid laminar flow. If I just use the latter, natural and hybrid laminar flow, for example, the team identified 2025 as the potential entry into service date for this technology. And then depending on the scenario, whether it's conservative or more optimistic, anywhere between 1% all the way up to 8% in CO2 reduction improvements expected from this technology. Wingtip devices is another example. So again, identify 2025 as the potential entry into service date of this technology. And then CO2 emission reductions of anywhere between 1 to 2%, depending on the scenario whether it's the low one or the high one. So in other words, we were able to tie each technology to a specific generation of aircraft that would be entering into service into the future, and that would be benefiting from the introduction of this new technology, right? And so as our 38,000 fleet strong evolves and some retires, we would start seeing these new generations of aircraft benefiting from these new introduction of technologies helping reduce CO2 emissions that would kind of create this overall evolution of our fleet towards more fuel efficient aircraft. Then what the working group did next, they reviewed each of the technologies and they agreed on a baseline scenario that we then took and used in our model. And the baseline scenario was basically an average between the low scenario and the high scenario, because we wanted to have a bit of a conservative approach when we were doing this exercise. I have to say that, you know, over my history with this project, it was the first time that I was experiencing and witnessing this level of collaboration across the industry on agreeing on what's the right set of assumptions from a technology standpoint. And it was really exciting to witness this. Given the amount of competition that our industry is used to, this was like a great example of us being able to put this aside and really focus on what matters for our overall industry. So if you move to the next slide, we did a very similar exercise for the SAF assumption. So we started from the ATAG waypoint report that was basically providing us a view, a forecast of SAF adoption for the whole aviation industry. And this report was laying out 5 potential scenarios representing different adoption rates of SAF across our industry that you can see represented in these lines, ranging from a very, max scenario, very optimistic scenario of SAF adoption, all the way down to very pessimistic scenario for SAF adoption. With our BACCC industry coalition, and again, the help of the Bombardier engineering team, we identified a consensus, which was to use the average of the high and high plus scenario that you can see highlighted in the red box at the top right-hand side of the slide, that was basically seeing a path for SAF to represent anywhere between 66% all the way to 81% of total fuel consumption by 2050. We then applied an emission reduction factor of 80%, which is the industry consensus for the amount of CO2 emission reduction that we get from using 1 unit of SAF as opposed to 1 unit of Jet A fuel. And that helped us calculate the expected average CO2 reduction from SAF adoption that we used again in our model. So you see highlighted at the bottom of the slide here in light yellow, the key assumptions that went for SAF adoption in our model. So how does that all play out when we rerun the model using these new assumptions and this consensus built through the BACCC industry working group? So if you go to the next slide and we go back to the same chart and we look again at how these assumptions are changing it, the bottom line is that we're now on track to reach about 4 million tons of CO2 emission by 2050 as an industry, which would represent about 70 to 75% reduction compared to 2005. Maybe just so that everybody is in the same ballpark. Back in 2005, we emitted as an industry for business aviation about 16 million tons of CO2 emissions. So we would go from 16 million tons to 4 million tons by 2050. So beating the target of a 50% reduction. Again, as I mentioned, this hinges heavily on technology improvements being introduced by our industry and a significant adoption of SAF. What we can also read from this chart, though, is that if we only rely on SAF adoption and technology, as well as on improvements from operations and infrastructure, which were, from the literature that we've used, expected to represent a 3% emission improvement reduction per decade, roughly, all the way to 2050. The bottom line is, this is not getting us to net zero by 2050. And you could hear it a lot again at COP26. You know, net zero by 2050 is really what we need to, as an industry, be able to support the Paris objectives of limiting temperature increase of at 1.5 degrees. So what we did next is we did more homework to understand when would we naturally hit net zero. And if you go to the next slide, if we were just to kind of expand the time frame of our forecasting to the next decade after 2050, what we were reading from our model, expanding the assumptions all the way to 2060, is that we would basically be hitting net zero CO2 emissions over the following decade after 2050, okay? Which was representing, we calculated, about 11 million tons that we would need to be offset in order to actually be able to hit net zero by 2050. So how do we get there? If you go to the next slide, the way we get there is it's really up to our operator community to offset these. Okay, and the good news is that there's actually really strong interest across the board, across operators and across all the associations to go in that direction and really leverage offsetting to help us get there. So if you go to the next slide, just to kind of wrap up on the three objectives, we're on track on all three objectives. And based on the work that we had been doing over the past several months, we went ahead and we proposed to introduce a new set of aspirational goals in light of the progress that we were seeing on Objective 1, the progress we were seeing on Objective 2, and the progress we were seeing on Objective 3. And if you go to my final slides, you will recognize the updated aspirational goals. So really on Objective 1, going from a 50% reduction in CO2 emissions by 2050 relative to 2005 to achieving net zero CO2 emission by 2050. On Objective 2, which was achieving a 2% fuel efficiency reduction between 2010 to 2020, based on the calculations that we did and looking at how things would be evolving beyond 2020 on fuel efficiency, we proposed to update Objective 2 and renew it to improve fuel efficiency by, again, 2% from 2020 to 2030. And finally, on Objective 3, continuing to be carbon neutral growth from 2020 onwards. So that concludes my presentation. And, Pete and Kurt, I'm giving it back to you.
Thank you, Thomas. And just as a recap, just again to emphasize to everybody on the study, what was the number of business aviation aircraft that that you guys projected that we based the study upon, the worldwide fleet?
The worldwide fleet that we used, if I just take 2020 as kind of the reference point, was about 38,000. 40,000.
That is one impressive number, that's for sure. And we hope to grow that, obviously. So that's our objective. So with that, I think any of us are willing to take any questions that we have from the audience. So Andre, do you want to kind of, I don't know if you've got any in electronically, or if somebody just wants to stick their hand up or come off mute and ask any questions.
May I ask a question? Leanne Shea with Aviation Week. Thank you for this fabulous presentation. You know, there's so many different things that you're monitoring and measuring. How does actually the fleet change take into this effect? Like, you know, the retirements versus the introduction of new aircraft. Thank you.
So absolutely. So we have the way the fleet model works is, as I explained, we kind of started from 2020 as our reference point, and 38,000 fleet strong for business aviation, both jets and turboprops. And we then use a forecast, which we call the industry consensus forecast, that comes from recognized third-party sources. So a forecast for both new jets coming in all the way to 2050 and turboprops coming in all the way to 2050 that get added onto our fleet. And then we subtract all the retirements that we again are forecasting all the way from 2020 to 2050. So this model really relies on a fleet forecast that looks at how our fleet will evolve from 2020 all the way to 2050, including the deliveries and the retirement. So I hope that this answers your questions, yeah.
It does, thank you. Do you happen to have the 2050 number?
I could probably get that back to you. I don't have it on top of my head.
If you could, that'd be great, just to kind of show, you know, where we are, and then in 2050, what does that fleet size show?
Sure.
Fantastic, thank you.
Sure.
Leanna, I would just add that one of the challenges that we have is to be able to also have our crystal ball forecast the growth of the electric and hybrid fleet in the out years. So one of the things that Thomas wrestled with was trying to sit there and look at when we would see production certificates and these new aircraft entering into large quantities. And as you know, right now, there's so many different designs out there and different technologies that are being explored. So, but the good thing is that all of those type of aircraft, the more that we have in the fleet, the better the numbers become. So that's why we're very encouraged by that. And we'd like to see the size of that fleet, which will be part of business aviation and how they will operate, grow as fast as it can. But we expect first type certification probably in the 2024 timeframe, and then it'll be a few years before they actually get produced in numbers to enter in any large quantities. But we're really encouraged by that. That'll make our numbers even look better.
Yes, hi, Kurt Epstein from AIN.
Hi.
Yes, Thomas, I have a question about when do you, in your forecasting, see the use of 100% SAF taking a large effect?
So as I kind of showed in the presentation, right now, given the window that we're looking at that goes all the way to 2050, and looking at the ATAC waypoint report, the maximum in terms of SAF adoption that we get to by the time we're in 2050 is, I'd say, about like 75% of SAF adoption. So we didn't really get to a point where we hit the 100%. Right? Even when we extended all the way to 2060, we were seeing this SAF adoption. We assumed to some extent that it would continue to grow. In the decade following 2050, I believe that we were getting all the way to about like 85% roughly, but we were not getting yet to the 100%. Again, this is really based on the assumptions that we used from the ATAG Waypoint report. Am I answering your question, Kurt?
So you're looking at 100% as a whole holistic number, not, I was more interested in when you start seeing specific aircraft and specific engine manufacturers being able to take 100% SAF. And of course, that also hinges on when 100% SAF is actually commercially available.
Yeah. I think that's more a question of, I'd say, rather than capabilities of the engines right now. That's pacing achieving the 100%.
Kurt, I would just add that as you know probably better than me, that many of our engine manufacturers are testing their engines on 100% SAF to look at performance parameters and everything. And we all know that right now the blend is capped at 50%. There are reasons for that. There's the different feedstocks have different aromatics that's associated with that. And one of the challenges that we have in business aviation is because we're keeping older aircraft out there, one of the things, all of this, as we have emphasized multiple times, SAF is Jet A. So it has a standard by which it is then rebranded once the neat additive gets put in there, and it is Jet A. That's capped right now at 50% because of our need to make sure that as you go beyond that all the aircraft in the fleet can take that with seals and everything else. So there is a lot of work that still remains to be done for all, whether it's commercial or business aviation, to look at the impact on the legacy fleet out there. It's much easier to do forward fit than it is retrofit on all of the different seals that are in all of those different aircraft to be able to go and go to 100% SAF. So we're confident that'll happen over time, but how quickly is still kind of nebulous out there in my mind. Kurt, do you have anything you want to add to that?
I think you summarized it pretty well, Pete. The issue is, ultimately as well, one of cost, whereas you can probably add into these blends more aromatics to get to that point where they're certain that we could raise the blend up to 80% or higher. But that also costs. And so the whole point behind SAF as well, or the point that doesn't get discussed as much is we want also to get it to a price that's comparable to that of traditional Jet A. So all of this is kind of coming together through these technical tests and seeing what is economically viable.
Any more questions?
Andre, can you mention where this briefing will be available to people?
Yes, so we have recorded this briefing, and so as well as I sent out the presentation first draft, so I can send out the final draft of this presentation as well to everyone following this. And then our hope is to have this up on our website in the next day or so, if you'd like to come back. But also, if you need the recording, happy to share that sometimes afterwards as well, before we get it on the website.
May I ask one more quick question? Sorry. This is Leanne. What do you think are the biggest challenges and what are the biggest opportunities that you see in all this? Like, is there something that really keeps you up at night?
Well, I think from the manufacturer's point of view, having so much energy right now between of people wanting, whether it's operators wanting to show their environmental sustainment credentials over time, or just manufacturers and maintenance providers and everything also being part of this ecosystem of wanting to get to net zero by 50, there are a lot of exciting things happening. I'm real excited about what we're seeing with additive manufacturing. And then the complement to that is fly-by-wire. As Kurt had mentioned, everything that we're doing is to lighten the aircraft up to increase performance, increase efficiency. And you couple that with the exciting things, I think some of you might have seen at the JetNet conference, a great brief by Rolls-Royce about power generation off of turbine engines and what we can do to augment the thrust that we get by burning, whether it's SAF or fossil fuel for the time being, and that augmenting that with electrical power. And what we can do is really fascinating. And so our goal is to, as manufacturers, this commitment of 2% per year now for the next decade, we hope to be able to accelerate that in the decade that follows with a lot of these technologies as they become more ingrained. So from the manufacturer standpoint, I'm really excited. And I'll let Kurt talk on the operator side, but it is fascinating when we talk to our companies that are providing SAF of the folks that are showing very strong interest in wanting to have all of their aircraft being able to fly in a sustainable manner. Kurt, you want to take that?
Sure. The opportunity is that right now, so many within the industry are aware of the situation and they want to do something. There's a lot of energy, no pun intended, behind wanting to find ways to decarbonize and trying to get at especially sustainable aviation fuels, which is kind of, from my point of view, that's what I'm using for because it's just not out there and available. And we need a whole lot of it as soon as possible getting made. And we hear frequently, well, we need to see the demand signals. But what we're also finding is that there are flight departments out there, while they're small, their fuel use is small relative to, say, an airline. They want to have up to 30% blend in their fuel tanks. They're making a commitment to a 50% blend, but they can't get the fuel right now, or they're struggling to get it, and they get it in dribs and drabs. So really, this getting SAF produced, scaled up, and available to the fleet is important. So whether that's through policies that we can encourage through national and state governments to encourage the production, whether that's through the availability of a book and claim system that would allow someone to purchase SAF, but it would be uploaded by someone else, somewhere else. These are all things that we need to have in place to kind of get this going. Because as you saw from the sand chart there, SAF is going to be probably among the most critical of the tools to get us to the goal of net zero carbon by 2050.
And Leanne, I would just reattack here with one of the things that does keep me up at night is the proposed tax regime in Europe based on the Fit for 50 proposal, and how I just think it's so discriminatory and unfair in its current form to business aviation, because the taxes start to be imposed here very soon, basically 2023, 2024 timeframe, whereas the commercial airlines get 10 years to phase it in. And I realize that in Europe, obviously there's a different approach. It's more incentivization on this side of the Atlantic versus mandates on the other side. But for us to be able to avoid taxes, we have to be able to use sustainable aviation fuel. But if you can only get it in their deployment structure at the large hub airports, which is what they have planned, and you don't recognize a book and claim system over there, and currently now it's not part of the proposal, we're working hard and we're getting help from our folks in the European Commission that we work with in what's called DG Transportation, trying to get set up meetings with the tax writers over there, because we have to have a recognized system of book and claim that they will allow us then to be able, as business aviation operators, to buy SAF that way and take credit for using it. Otherwise, this tax is very debilitative on the industry, and I am extremely concerned about it. And I think it's just a matter of fairness that we have a recognized mechanism that allows us to purchase SAF until the quantities over there are available in such form that it's available at the airports that we use, in addition to what our commercial brethren use.
Thank you both for that.
Okay, anything else? Well, again, if folks have any questions, we love to talk about it. Between Rick and Mark there, or Bruce and Mark, they are our true experts, and they work this day in and day out, and they could talk your ear off on a lot of these subjects. So please don't ever hesitate to reach out to us either at GAMA or IBAC to be able to answer questions, because we're all in this together, and we really rely on you to be able to get the word out to this entire community to make sure they understand what direction we're all going, and the importance that everyone can speak SAF properly, that understand that SAF is jet fuel, and that every aircraft can operate on it, and that people want to get it, and give us any ideas that they have about how, if they're talking to their colleagues and they're having problems trying to get into a book and claim system to be able to purchase it, we'd like to direct them toward resources to help them out. So, Andre, pass it back to you.
Well, again, thank you everyone for joining us. As Pete said, if you have any questions, please feel free to reach out. I'm happy to also make this recording available as soon as I can. With that, I wish everybody have a great day.